Hi everyone, my name is Herman Ryer and I will be doing a presentation about Z-scores, and this is for marketing statistics. So I first want to start off my presentation by talking about what Z-scores are exactly. So a Z-score lets us know how many standard deviations a value is from the mean. We do have the formula here for Z-scores, in which represents the Z-score, X is represented by the value, U is represented by the population mean, and that is divided by the standard deviation. So how do we interpret Z-scores? Well, if 0 is greater than the Z-score, that means that the value is less than the mean. So if the Z-score is greater than 0, that means that the value is greater than the mean. If a Z-score is equal to 0, that means that the value is the same as the mean. If the Z-score is equal to positive 1, this means that the value is one standard deviation greater than the mean. And on the contrary, if it was minus 1, that means that the value is one standard deviation less than the mean. So here we have a bell curve for the Z-scores. So at the bottom, you can see it ranges from -3 to +3. So depending on what Z-score we get, we would fall on a different part of the bell curve Z-score chart. I'll get back to this after I show you my couple examples later on in the presentation, and we will see how it relates back to the bell curve. So the next question is, why do we use Z-scores? Well, it helps us compare individual scores. In the examples that we'll be using later to explain exactly what this is, we will see that you can apply this to many different situations. So for one, we have it for the mark that a student got on one of their tests. Another one, we could apply it into sports, comparing goals amongst one another. This will all be shown later in the presentation when I explain my examples. So the Z-scores standardized data scores, and this quote is actually taken directly from StatsLard, and it allows us to calculate the probability of score occurring within our normal distribution. So I know that sounds a little bit complicated, but let's get into an example and we can see how helpful and easy Z-scores are to use and how we would apply it into our day-to-day lives. So we have a population of 120 students who wrote a test. So the professor grades the test and he finds out that the average was 65% and the standard deviation was 12. By 12 we mean 12 marks. So one of the students scored a 74 on the test and wants to know how he did compared to the rest of the class. So we would use Z-scores to determine this. So first things first, we're going to go back to our formula for the Z-scores and we're going to plug in our values. X is 74, that is the mark that our student received. U is the mean, which is 65, which was the class average. And the standard deviation we stated was 12 marks. This gives us a Z-score of 0.75. But what do we do with this Z-score? What does this 0.75 mean? Well, what we do is we take it over to our Z-score chart and we find where they intersect. So we had a score that takes us to 0.75, which takes us to 0.7734. So what does this mean? What does the 0.7734 mean exactly? It shows us that the student did better than 77.34% of his classmates. How do we figure out how many students he did, are we able to figure out how many students he did better than? Absolutely. With all this information that we have, we are able to figure it out. We would take the number of students that wrote the test and multiply it by this 77.34%. So as we stated earlier in our example, 120 students have written this test. So we take 120 and we times it by the 77.34%, which we have to convert over into a decimal, which takes us to 92.8, which is rounded off to 93 people. So with us using this Z-score, we are able to come to the conclusion that student X did better than 77.34% of the students in the class, or better yet, did better than 93 other students. So I wanted to provide another example how we were saying we could also apply this to something, say, like sports. It doesn't just statistically have to be math. We're going to apply this to sports, and we can see that we have a 17-year-old boy whose name is Jacob, and he's in a AAA hockey league. And there's 140 people in the hockey league. So right now he's currently sitting at 35 goals, and the league average for goals is 28. So we have a standard deviation of 3 goals. Given this information, are we able to find out how many players Jacob has more goals than? Absolutely. We would do exactly what we did in the previous example, and we can apply this to something like sports and see how Z-scores can be used for multiple purposes. So again, what we do is we get our formula and we plug in the values. So we take 35, we minus 28, and we divide it by 3. That gives us a Z-score of 2.33. So what do we do with the Z-score? The exact same thing that we did in the previous example. We go over to our chart, and we can see that the percent would be 2.33, which is 0.9901. Given that 9901, we're able to determine that Jacob has more gold than 99% of other players in the league. So he is doing tremendously well in this league. Can we figure out how many players he has more goals than? Of course we can, because we would just do exactly what we did in our previous example. And we would take the number of participants in the league and multiply it by the Z-score table value. So as we stated, there are 140 players in the league. So we take 140 and we times that by the 99.01%, which is 0.9901 as a decimal, and it rounds off to 139 people. So in conclusion, Jacob has more goals than 99% of other players in the league, or more than 139 people in the league. This is why Z-scores is so valuable. We can apply it to so many different situations and get an exact number of what this data means, and it really gives us a way of comparing individual scores amongst one another. Here are my references for the assignment. I want to thank you all very much for taking the time to listen to my assignment, and I hope you learned about Z-scores.